All right, ladies and gentlemen, hello again. This is the third time we're going to try and record this lesson. The other two I tried doing with the Elmo and writing everything out that way and just recording it off that, and none of it worked. So we'll try it third time's a charm. Anyway, so here's trig shifting with sine and cosine. And basically what I've highlighted here are the two generic forms that I want you guys to pay attention to. So the idea here is that you still are going to have your A and your B. So think of it this way. Yesterday, what you guys were graphing, you guys were actually graphing the parent functions. Today, we're going to add the extra step of the shift part of the h and the k. So just like we had in the past, when you have your horizontal is your h, so that goes with your x's, and then your k is what you work with your y. So you have your h and your k, your horizontal and your vertical. So these are the two main things I want you guys to pay attention to as we go through. Remember, the a, the b, all that stuff still works the same. It still helps you find amplitude, find period, and so on and so on. So what I want to do is jump directly into a more of a complex looking problem. So in this case here, we've got 2 sine of 2/3 x minus pi over 4, all subtract 3. Now, just like we have in the past, we would always set these things up. We always start by writing out what our a value is, and here our a value is, is 2. Our b value is the 2/3. Our h value is the pi over 4. Remember, it's x minus h, so this is the h value. And our k value is -3. I apologize for the handwriting. It is so difficult to write on a screen with the stylus. It just does, and the screen doesn't fold flat. It's just really difficult to do this. Do that. So anyway, to find we know our amplitude, just like we have before. Our amplitude is 2. Our period is going to be 2 pi divided by 2/3, which means you get 2 pi times 3 over 2. So our period for this function is 3 pi. Now, I want you guys to think about what we did yesterday. When you set up your stuff, we knew that in this case, excuse me, we knew that in this case we had an h and a k value. Our h value was pi over 4, our k value was -3. So we know that our graph is going to wind up being shifted to the right a little bit and then down a little bit. So when I go through this, normally what I like to do is I might overdraw my axes when I go to put it all together. Here's what I mean by that. I know that I have to go move it downward, so notice how I move my line up, so there's a little bit more space down here. So we know that we have a parent, and then our shift. So our parent functions, we always graph from our period. So we'll put our 3 pi out here, cut it in half, so we get our 3 pi over 2. This is exactly the same thing we did yesterday. 3 pi over 4. Now I want you to think of it in terms of fourths, 3/4. So we have 3/4. This is 6/4. Then this would be 9/4, because 3 pi is the same thing as 12/4. Our amplitude is 2, so we go up 2, and we have to go down 2. Label it here and here. I believe this was a sine graph, so remember, sine always starts at, sine always starts at 0 for the original. So we'll put 0 here for sine. It goes to the a value. In this case, the a value was 2. It returns back to 0. And it goes to the opposite. Oh, I'm sorry. That one was in the wrong spot. It goes back to 0. And then it goes then to the opposite of a. And back to 0. So our parent function always gets a dotted line as we go through. And now what I want us to do is list out our ordered pairs. And this is where my handwriting is going to be kind of tough here. So our ordered pairs for the parent were at 0, 0. And then it went to 3 pi over 4, comma 2. After that, it went to 3 pi over 2, back to 0, 9 pi over 4, -2, and then 3 pi, back to 0. Now our shift, remember, we're going to take all these values of x and we're going to move them to the right, pi over 4. And then all my values of y, I believe it was they have to move down 3. So the idea of taking all of these as ordered pairs first, now all I have to do is the math of the shift. So I add pi over 4 to 0. I subtract 3. Add pi over 4 and all the way down. And when I do all this, let's see. Again, I apologize for the handwriting here. So I'm at pi, -1, 7 pi over 4, and -3, 5 pi over 2, and -5, and then back to 13 pi over 4, and -3. Remember, all I'm doing is using some common denominators and adding and subtracting there. Okay? So we know that each one of these points to start with, all these guys that we started with the parent function, are all getting moved over to the right just a smidge by a pi over 4. So now I have all of my new ordered pairs here. I know that my farthest to the left one is pi over 4, so I just mark it. And I put my pi over 4. Let me change the color of this real quick here so you can differentiate between the two. So I have a pi over 4. And then the next one would be at pi. And the next one was at 7 pi over 4. And then we are at 5 pi over 2 after we simplify our fractions. And lastly, 13 pi over 4. Now we have to go and look at our y values. All of our y values are going to be moved downward. Our lowest point now is going to be at -3, -4, at -5. Now I just go through my ordered pairs here. So I'm at pi over 4 and -3. I'm at pi, -1. 7 pi over 4, -3. 5 pi over 2, -5. And then back up. From here, we just kind of roll through. Okay. So that's the idea of a sine graph. And let me show you a real quick a cosine one. The cosine one really isn't any more different or any more difficult to it, to be honest with you. But I'm just going to set this up with the parent and the shift, and I'll let you guys graph it. So let's look at this one. So let's see. We have y equals -1/2 cosine parentheses 2x plus 3 pi all plus 1. Now remember the generic form. The generic form was when you had y equals a cosine parentheses, excuse me, oops, sorry about that. Change this back, I wish it would just stay there. So a cosine, and then it was b parentheses x minus h plus k. Notice here, now this b value should come out. So what we have to wind up doing is we have to factor out the 2. And that's kind of the tricky on this one. That's why I wanted to show you something like this. We haven't had one like this yet. So 2 cosine, 1/2 cosine, and then I have to clear x. And this just becomes 3 pi over 2. Okay? So same idea. Oops. Can't even put my hand on the computer. It moves everything. Same idea. Label everything out. We have our a at -1/2. Our b value is at 2. Our h, since it's a plus 3 pi over 2, that means our h is -3 pi over 2, which tells me I have to move things to the left. And then our k value is 1, so it's got to move up. So we have our parent and our shift for the ordered pairs. Remember, the shift in this case is going to be x minus 3 pi over 2. So that's a 3. And the y value would be plus 1. Man, writing on the screen is terrible. All right, so from here, we know our period is it's going to be 2 pi over 2. So our period is pi. Our amplitude is 1/2. Remember, the amplitude is always the absolute value of a. So we know that this has to move to the left. So what I'm going to do is kind of over-exaggerate, have a little bit more space on the left-hand side of the axis to move things around. So let's see, our period is at pi, so I'll put a pi out here. And cutting the breakpoints for this one's going to be really easy. Oops, slide this up a little bit here. Breakpoints, we have pi over 2, pi over 4, 3 pi over 4. From here, we know that the amplitude, mark it off at 1/2 positive and 1/2 negative. This was a cosine graph. Remember, your cosine graphs always start at the amplitude, whatever your a value is. Cosine always starts at your a value. Our a value here in this case is negative 1/2. So I have to plot my first point at negative 1/2. Then I go to 0, opposite of a, back to 0, and then back to a. And this becomes my, okay, can't even draw a dotted line anymore. There we go, I guess, whatever. And it gives you your ordered pairs. So your originals, we are at 0, negative 1/2. This is very annoying. And then we're at pi over 4 and 0, pi over 2, 1/2, 3 pi over 4, and pi. Those are all my parent functions. Now remember, we have to do the shift. So when we do the shift, we wind up then with each one of the x values, I have to subtract 3 pi over 2. And each one of the y values, I add the 1. And we wind up with negative 3 pi over 2 and 1/2. We get negative 5 pi over 4 and 1. Negative pi and 3/2. Negative 3 pi over 4 and 1. And lastly, we are at negative pi over 2 and 1/2. So remember, when I'm setting these things up, by doing this from this first ordered pair is all the way on the left, which means this one is also going to be the furthest on the left. So if you keep these things in order, going from left to right for your ordered pairs, by keeping them in some semblance of an order, when you rewrite it all out, you just follow the same pattern. So we know where your breakpoints are. Here's negative 3 pi over 2. Then we're at negative 5 pi over 4. And then we get to negative pi, negative 3 pi over 4. And then lastly, we're at negative pi over 2. Okay? From here, you also have your, you know where all your y values are at. So all of our y values, it just has to go up to 1. And then we have another one up here at 3/2. So you just start plotting it from here. So let's see, negative 3 pi over 2, 1/2, it goes to 1, it goes to the 3/2, back to 1, and then back to here. And there's your parent. I apologize for the graphing with the stylus here. It's not the easiest thing to write with. I'm going to have to figure out some other way of doing this. Maybe I'll have to use some other way of recording the Elmo, because the Elmo is much cleaner. I'll post the pictures of what I did with the Elmo on this lesson as well, so that way you guys can see them. So hope everything's going well, and remember, wash your hands, and we'll see you guys soon. Thanks.